for taking time out of your Sunday to attend this talk. I'll be giving a session on basically effective strategies of how to visualize multidimensional data. Since we have 25 minutes, so we'll try and cover the basic concepts around the grammar of graphics and how do you effectively use it for multidimensional structured data. You can get all the code and the slides here so that you can refer to it in the future. The basic agenda is understanding what is data visualization, why do we need it, how do you do effective multidimensional data visualization using the grammar of graphics, a brief into the different frameworks which are available in the market nowadays with Python, R, and even commercial tools. And also, the main focus is visualizing structured data, like how do you go from 1 dimension up to 6 dimensions. Dimensions here basically being your columns or features of the data using grammar of graphics. And assuming we have enough time, I'll also show you some interesting stuff around how do you visualize unstructured data like text, images, and audio data. And the final concluding words. So a brief about me, I'm basically a data scientist at Intel and also have a passion for sharing things. So I mentor students as well as write several articles, books, papers around data science and machine learning. So a brief intro into the what and the why of data visualization. The key idea at the end of the day is to do effective storytelling where we leverage data to find out meaningful insights and patterns by communicating it with the right visuals. And what are these visuals? Essentially, you're doing data visualization, which is an effective technique of using pictorial representations, can be in the form of charts, can be in the form of images, diagrams, or even animations, where you are conveying some effective insights, converting the data into useful information. And as you can see, since the days of traditional BI or business intelligence into the age of AI as we are advancing artificial intelligence, it's still a very powerful tool because you can communicate information effectively, and also we as humans have been wired to find out patterns from data. And as you can see, we really process visual information really well, as you can see in these stats. Like 90% of the info transmitted to the human brain is visual, and we can process visuals almost 60,000 times faster than text data. And if you see any image, like within a matter of a fraction of seconds, you can kind of understand what the image is really trying to convey. So a bit of more detail as to why do we really need data visualization. So this is an interesting data set known as the Datasaurus dozen, which is basically 12 different types of data, as you can see here, data points. So what is really common in all these images? So as you can see, the summary statistics is exactly the same. The data set is really different, as you can see, from the alignment of the points and their orientation, but the summary stats is the same. And this is kind of like a novel, I would say, outlook on the Anscombe's quartet, which many of you might be already familiar with, where you have 4 different types of data points or data sets, and they have the same summary stats, mean, standard deviation, correlation, and so on. So what this tells us is don't just blindly start engineering features from your data, be it taking mean, median, or extracting confidence intervals, doing statistical tests, hacking around with p-values, but really visualize the data and try to understand what's going on and what are you really dealing with at the end of the day. So now going into effective multidimensional data visualization. So the grammar of graphics is nothing new. It has been there since the 1980s when Wilkinson kind of introduced it in his book. But what we are really going to talk about is an advanced approach where Hadley Wickham, as many of you know, the creator of the ggplot2 package, he kind of adopted that theoretical grammar of graphics and made it more practical and implementable by code, where you can use a layered hierarchy of different layers here, which you can use to build up a structured visualization without randomly hacking around with what points do I need, what kind of visuals do I need, how do I represent the data, and so on. So these are the major components in the grammar of graphics. Obviously, there are more layers, but considering you want to build any visualization on structured data, right, and really visualize multidimensional data, I would say these are the 7 layers which you really need at the end of the day. Always start with the data at the lowest level, what kind of data you're dealing with, the features, the data points. Think about the aesthetics. So what are the aesthetics? Basically, what are the plot positions you need? What are the axes? What is my x-axis, the y-axis? Do we need to encode any categorical variables? or basically any continuous data into discrete data, things like that. Then comes the scale. Do we really need to scale the values? Do we really need to bin some specific values? Aspects like that. Then comes the geometric objects on top of that. How will we really represent the visual? Is it going to be a point plot, like a scatter plot? Is it going to be a line chart, a bar chart, or a histogram? Aspects like that, that's your geometric objects. Statistics is kind of optional. It's if you want to view some trend lines, some spark lines, or the mean, the confidence interval, quantiles, aspects like that, you can put that also in the plot. The next layer is perhaps one of the most important layers. Facets are basically focused subplots which focus on visualizing your data through multiple dimensions. So basically you represent each subplot depicting for a specific dimension or feature, and in that subplot you also have other features coming into the picture so that you can truly visualize multidimensional data, and we'll actually see that later through some examples. And the last one is a coordinate system, whether you want to show it as a Cartesian coordinate system or a polar coordinate system, aspects like that. So the key aspects from this would be your data, your aesthetics, your geometric objects, scale, and facets, which are used more than often to build that layered visualization as you start adding these components one by one. So how do we do that? Always start with the data. So there is a ggplot2 in R, as you know, which extensively uses the grammar of graphics. In Python, you have ggplot, but unfortunately, that library is not maintained since almost 2 to 3 years now, and with pandas pushing a lot of new upgrades which are kind of not compatible with previous versions, ggplot breaks, especially if you want to do statistical measures and other aspects. So I would recommend to check out plot9, which is a great library, which is same as ggplot, but it's updated and in active development. So we'll be checking out the motor cars trend data set. So I'll just show this notebook because it's not visible here as well due to the low resolution. Hopefully you all are able to see this. Okay. So the motor cars trend data set is basically a data set about different cars and different statistics about them. A lot of you might be knowing this data set, like the miles per gallon, the number of cylinders, the number of gears in the system, whether the system is having an automatic transmission or manual transmission, whether it's having a V-shaped engine or a straight engine, and number of carburetors, number of cylinders, and so on. So always start with the data, and now let's say we want to visualize 2 dimensions. So what do? We basically call the ggplot function, mention the name of the data set, as you guys can see here, and then mention the aesthetics. So we start off with what is my x-axis and my y-axis. So my x-axis here is obviously weight, and the y-axis is miles per gallon, as you can see. And we basically add in this geom point. So as you can see, it's a layered structure, right? We are adding one component after another, and geom point basically tells it that this is going to be a dot plot or a scatter plot. And in this way, you can visualize with 2 dimensions or 2 features, and you can see here that there is a downward trend in general, where higher the weight, lower the miles per gallon. And theme underscore BW is just a black and white theme. Now suppose we want to go to the next level, right? 3 dimensions. What do? One way is to represent it by color. So what we do here is we still mention the aesthetics of the weight and the miles per gallon, my x and the y-axis. And we also tell it that take in the gear variable, treat it as a factor variable. So factor in R is basically a categorical variable. That is what we tell here even in Python, that treat the number of gears as a categorical variable and use the color aesthetic in this case. So aesthetics can be color, shape, size, position, and so on. So in this case, we tell them that use gear and represent it by the number of colors, different colors for each discrete category. And as you can see here, the number of gears get represented with each categorical value based on a different color, and it's shown in the legend here. And you can clearly see that cars with a lower number of miles per gallon and a higher weight have lower number of gears. The next aspect is if we want to add in another dimension now, going from 3D to 4D, what do you do here? So take into account your aesthetics with color as well as shape. So what you can do here is, by shape I mean size here. So you have the color again, which is your factor, and what you do now is you tell that the number of cylinders is basically my size. So represent each category or each discrete categorical value in number of cylinders with the size. And as you can see here, that is exactly what we have done. And as you can clearly see from this plot here, that as the number of gears decrease, the miles per gallon also decreases, and the number of cylinders also becomes more for those type of engines. So using this, you can clearly visualize multiple correlations and multiple dimensions or multiple features in the same plot, because at the end of the day, you are still limited by the two-dimensional screen, whether you're using a laptop or a smaller form factor like a phone or whatever be it. And like I said, if you want to view trends, what you can do is you can use the stat smooth method. That's basically telling to use different statistics. Like in this case, I want to view a linear trend line. That is, the LM is the linear model. So in this case, you can clearly see the trend lines as to, for each class of cars with different gears, like 3, 4, and 5, what kind of a trend happens with miles per gallon and weight. So that is why we use here the same aspects. As you can see, we just keep adding a new layer because it's a layered hierarchy, right? Grammar of graphics. So we just add in this to the previous plot, and we can then see the trends also along with all the previous aesthetics with regard to the weight, the miles per gallon, and the factor. Another way of visualizing four-dimensional data is, instead of, besides the color, right, we have the x-axis, the y-axis, we have the color, 3 dimensions are covered. Instead of the size, we can also use facets or subplots, which is often more effective. And that's what we have done here. As you can see, we have our data set, we have our aesthetics, which is our x-axis is my weight, my y-axis is the miles per gallon. Color is the number of gears as before, and what we have done here is, instead of size for the number of cylinders, we are representing it with facets. So the function here is facet wrap, and we specify that use the number of cylinders here, and that is exactly what is represented on the x-axis here, where 4 is one subplot for all the cars with having 4 cylinders, 6 cylinders, and so on and so forth. So as you can see here, again, basically getting the same insights, but often size is harder to interpret, so there you can use facets. And how do we go to 5 dimensions? So since you are limited by the number of aesthetics you can use, you have to kind of use what you have got. So you use the size, you use the color, and also you use facets. So here we are representing color as the 3rd dimension with number of gears, cylinders as the size, and we are using automatic or manual transmission of the cars as the x-axis facets. So 0 is basically all cars with automatic transmission, and 1 is all cars with manual transmission. And as you can clearly see, that cars with a lower number of gears in general and basically higher number of cylinders are kind of having automatic transmission as compared to manual. And the last one is pretty much where we go to 6 dimensions from 5, where we represent with multiple facets, where we have our x-axis here represented by the number of carburetors, and the y-axis here, the 0 and the 1, is what we talked about before, the automatic or the manual transmission. So basically, starting off with the x and the y-axis here, weight and the miles per gallon, taking the number of gears as the color, the number of cylinders as the size, and specifying that it's a point plot, and then specifying the facets, where on the x-axis, typically you have the number of carburetors specified as different subplots, and on the y-axis here, the 0 and the 1 specifying the transmission, whether manual or automatic. So these are the 6 dimensions which you can visualize together. Can you do more? Definitely, but you have to kind of hack around with it, where let's say you want to visualize a 7th dimension, you have to kind of build these facets again, but you have to separate out your data. Like if your 7th dimension, let's say, is a V-shaped engine or a straight engine, 0 or 1, what you do is you separate out the data for the V-shaped and for the straight engine, and then you build these same 2 plots again for each of them. So essentially, it's like, since you're limited by the 2-dimensional screen, in one complete plot, you can go up to 6 dimensions, but you can create multiple versions of this for other variables. And other than that, there is the dimension of time. So if you have time into the picture, you can always create an interactive plot. There is bokeh or other frameworks in Python where you can use a slider and show the 7-dimension as time, but that's limited to time series data. So coming back to the presentation, so these are exactly what I was talking about. I just showed through the notebook because the resolution is kind of low here, but moving on to the next aspect. What are the different data visualization tools and frameworks? So popular ones including open source and commercial, you have D3JS, which can be coupled with Python, where Python feeds in the data and you can visualize using an interactive JavaScript-based framework. You have Tableau, Excel, Fusion Charts, HiCharts, Leaflet. Plotly is a very important library which you can use in Python R as well. And there is Kibana, which is basically the open source stack which Elastic has built, Elasticsearch, Logstash, Kibana, where you can feed in data through Elasticsearch and visualize through Kibana. Popular Python visualization frameworks, you have Matplotlib, obviously the core foundation. Then you have Plot9. Pandas also, by default, you can use it for plotting. Seaborn is one of the most popular frameworks out there, and you have Bokeh, which provides interactive visualizations. Plotly is also there again. And why I've mentioned our visualization frameworks again is because ggplot2 is kind of what really revolutionized the whole aspect of kind of plotting multidimensional data, right, using the grammar of graphics. So usually following a structured method instead of hacking around with the data and kind of building layer by layer and building the visualizations. And you have ggiraffe, which provides interactive visualizations into ggplot2 and tau charts. Plotly is again there pretty much where you can plot interactive charts and share it with the community. A bit more into visualizing structured data, so kind of taking a more complex data set here where it's the wine data set, providing different physicochemical properties of red wine and white wine samples. This is available openly on the UCI machine learning repository. I've taken the data set from there. You can check this out later also in the slide deck. The description of each variable is present there, or each dimension, and it's even there in the notebook. So acidity of the wine, the residual sugar in the wine, different types of acids, sulfur dioxide, the quantity of that for red and white wine. So how do we start with visualizing this data? You can start off by just plotting a histogram. If you have a data frame, just call a .hist, and you can start seeing the patterns in your data. How is my data distributed for each variable separately? That's why this is univariate analysis. And you can then dive into each specific variable where you specify axis.hist, and you inside the hist function you specify which variable you want to visualize, and you can even plot summary statistics like the mean, median, and so on, and kind of visualize, is the data skewed, is it normally distributed, do I need to transform the data, are there outliers, and so on. For discrete data, you can go for a bar chart. There are pie charts, but if you have more than 3 or 4 categories, it doesn't really look that well, so I would recommend using bar charts to kind of visualize frequency of different categorical values in one dimension or one variable. Going to bivariate or 2 dimensions, you can start off with a correlation plot to visualize what kind of correlations are there in your numeric features, and then you can even plot it as a heat map if needed using Seaborn's heat map function and pass in the correlation matrix. And as you can see here, alcohol and density are having a really negative correlation because alcohol is much lighter than water in general, and that's how density is measured. So you can start finding out these kind of interesting insights and go further into a pairwise plot, as all of you might know, and use a scatter plot and kind of visualize what kind of patterns might be there using Seaborn's pair plot function. That's the function which we used here. And you can even restrict to the specific columns you want to visualize. And then you have other aspects where you can visualize categorical data using a bar chart, and Seaborn's count plot is a great function. You just pass in your x and the y axes, and in this case, since we are visualizing 2 dimensions, what we can do is we can just say that I want to visualize the different types of wine samples and represent each wine type by the hue, which is the color. So using the color aesthetic here. And you can do the same thing again for even continuous data where instead of a bar chart, you have to use a histogram and use the color aesthetic again and use a Seaborn's dist plot function, which typically shows you the distribution of your continuous data, in this case, the sulfate distribution for red and white wines. And as you can clearly see that red wines typically have a higher sulfate content. And if you have more number of categorical variables, you can use box plots or violin plots and represent your categories in the x-axis and so on. Going into 3 dimensions, is this plot really effective? Not really, because the notion of depth is very difficult to perceive on a 2-dimensional screen. So what you can do is you can bin one or more attributes, one or more numeric attributes into discrete, and you can still use a 2-dimension plot by using faceting. So residual sugar is a continuous variable. What I've done is I've taken the quantiles, as you can see here, or percentiles, with 25th percentile, 50th, 75th, basically that range, 0 to 25, 25 to 50, and so on. And as you can see here from this clearly, what we can see is the higher quality wines are right at the top, and they have lower amount of fixed acidity as compared to the wines with a lower alcohol content. And we'll see the reason for this shortly, as to why when the residual sugar increases, the fixed acidity kind of decreases, as you can see here. So visualizing 3-dimensional, if you have 3 categorical attributes, what you can do, you can use a combination of color, you can use a combination of facets, and obviously you have your other aesthetics like the x-axis. So basically using a combination of color, facets, and the x-axis to show the distribution of data for 3 categorical variables. And if you have a mixture of continuous and categorical data, you can use, like I said, box plots or even violin plots, and represent it using the notion of color and your other aesthetics to kind of visualize this data. So going up to 4 dimensions, again, is this plot effective? Maybe to some extent. As you can see that the red wines have a lower amount of, or a higher amount of fixed acidity as compared to the white wines, and red wines have a lower amount of residual sugar as compared to the white wines. But this becomes really effective when you represent it in the form of a facet, as you can see here. And this correlates with the previous plot which we talked about, right, where as your residual sugar increases, the number of red wines decreases, because red wines have a lower amount of residual sugar as compared to white wines. And typically the fixed acidity also kind of starts decreasing. And there are multiple other examples here which I'll kind of skip due to the interest of time, but you can check it out where you can leverage a combination of facets and color, shape, size, and kind of start understanding that, okay, high quality wines are really having a lower amount of volatile acidity as compared to medium quality wines, so on and so forth. And always facets are more effective than size in general, because you can clearly understand what's happening with regard to each subplot. Understanding the notion of size becomes really difficult, because visualizing with regard to different spherical content in your plot, it becomes difficult to say whether the size is increasing or decreasing when you have a lot of data points. So we still have a fair bit of time. I'll quickly cover the visualizing unstructured data aspect. So what is the best way to visualize unstructured data like text? You can use word embeddings to kind of see what is the semantic similarity between words. And this code is there in the notebook. You can even run it on your own. This is what I had done by using the word-to-vec model and using both skipgram as well as continuous bag of words models separately, and do a PCA and visualize your word embeddings. And as you can see here, aspects around Egypt or Noah and his sons, famine, pestilence, Jesus and all the other disciples, they are kind of getting clustered together because they have been mentioned in similar contexts multiple times. And what do you do when you have documents? You can use doc2vec, or you can even use word2vec and aggregate based on each document for each word embedding, and then you can cluster on it and kind of start finding similar categories together, where you can use PCA, you can use T stochastic neighborhood embedding, and you can then start visualizing this data. Going into image data, at the end of the day, image is just a combination of pixels, where each matrix or each channel of the image is represented by a 2-dimensional matrix. So considering this is your image, you can basically represent it in the form of this matrix where each channel is basically the R, G, and the B, red, green, and blue channels. So how do you visualize data? Ultimately, why you should visualize the data is so that you can use it for something, right? Be it machine learning or building a deep learning model, aspects like this. So some ways of doing this is basically checking image intensity distribution. What is my image intensity based on the pixel values? What you can do next is use edge detection techniques to kind of check where are the edges in my image. And why do we do this? So that we can extract these as actual features at the end of the day to feed machine learning or a deep learning model. Same goes with histogram of oriented gradients or HOG features, where you count occurrences of gradient orientation in localized portions, and you can kind of extract features from this to feed machine learning models. And the last part of the images is basically CNNs, as you know, change the world. So you can really start understanding how does a deep learning model extract features, and from each layer you can try and understand, right? In the lower layers, it will extract features which are kind of generic, right? Like edges, corners, aspects like that. And as you start going higher up, the features become more specific to the kind of classification or image recognition you're doing, like in this case, the faces. So these are great ways of visualizing and really understanding, like how do you explain how a CNN model is predicting that this is a cat or a dog. Check out each layer, see which neurons are getting activated. That is how you can explain, because explainable AI at the end of the day is a really important thing which is becoming nowadays. I'll just take maybe 1 or 2 minutes to finish this up, and then we can open it up for Q&A. So how do you visualize audio data? Like, how do you see what you can only hear, right? This is a very interesting aspect. So what we did was we checked out this urban sound data set, which has around 8,000 examples and 10 classes at the end of the day. So one way of visualizing audio data is you have 10 different types of sounds occurring. It's a classification problem. You can start by doing a wave or an amplitude plot. Or what you can do next is use a MEL spectrogram. So a spectrogram is basically a visual representation of how does your audio data really sound, or how does it look like based on the amplitude scale. And basically, as you can see, different MEL spectrograms are there. Now, what we thought was, if we have a visual representation of audio data, can we apply transfer learning here? So that is exactly what we did. We extracted that image data. We kind of built a 3-dimensional representation of the audio data, and we used transfer learning, where we used a model. As all of you might be knowing, there is Inception, VGG, or whatever. Use that as a feature extractor, and then extract the features from the sound data. And in this case, sound is converted to image data, and that is exactly what we used. And we got a decent accuracy, around, I think, 89%. You can check out in the notebooks, which I may not be able to show due to the interest of time. So that's the thing. You visualize your data, and you get new perspectives around it, and you can think of solving a problem in different ways. So that is the main intent of this talk at the end of the day, that go out and visualize your data, use domain expertise to focus on important features, use dimension reduction techniques as needed, and remember to scale features, remove outliers, and so on. And last but not the least, a very famous saying by Geoffrey Hinton: if you want to visualize 17 dimensions, visualize 3 dimensions and say 17 over and over again. That's how everyone does it. So references and content, you can check this out, and I do a fair bit of writing. If you're interested in collaborating or research, feel free to write to me or message me. That's all.
Hello.
Hey.
Yeah.
Hey.
Yeah.
Go ahead.
First of all, wonderful talk. So I have a question regarding which one will you prefer in what case? For example, you mentioned about plot9, and you also mentioned about Seaborn. Now, Seaborn and plot9 can do a lot of things similarly, right? Like multifacet and those kind of analysis. So when you will prefer plot9 and when you will prefer Seaborn?
Yeah, so plot9 is kind of a translation of ggplot, so it's great to use, but in general, I would recommend to use Seaborn. Matplotlib, the only thing is you have to write a lot of code, so you can bypass all that by using Seaborn, so I would recommend Seaborn. And if you're going for interactive visualizations, Bokeh is a great one, like Travis today gave in the keynote, some interesting stuff, so that would be my recommendation.
Hi.
Yeah.
Am I over here?
Yeah, go ahead.
The example that you have given regarding CNNs is a famous example of DeconNet, right? Do we have anything in that manner for RNNs? to visualize how the network is working?
Visualizing RNNs, not really. There is something around memory networks where you can visualize which aspects of, I would say, a sequence-based model in text kind of are really firing. So in RNNs, honestly, I haven't really seen much, but if you are using memory networks along with RNNs, you can really see that which sequences of words are getting fired at each instance. I had seen that for an image captioning model which we had developed, so that, but other than that, I don't think so.
Okay, sure. Thank you.
Guys, sorry,
Please.
we would love to have some more questions, but due to interest of time, we'll have to cut it short.
Yeah.
So you can reach out to Dipanjan outside in the foyer, and you can talk to him and have your questions answered.
Yeah, I'm there, so feel free to reach out to me.
Yeah, Prithvi has some announcement.
Oh, for this? Okay. Okay, so they'll be giving away some goodies. So some questions. So okay, one question would be, so how would you define transfer learning? Let's say.
So he raised it first.
Okay,
Can you
go
please
ahead.
come? Go on.
How many questions?
You are basically want to ask 3 4 answers. I have one. Can I ask?
No, go ahead. 3 questions.
What you probably use a trained network and just use it for some other purpose and transfer its learning to get some new stuff out of it.
Okay. And some examples. Can you tell some examples of
We
transfer?
can use train ResNet, train VGG, and classify entirely different thing using
Okay.
that.
Cool.
You have a question to ask?
Can you please come up?
I am about to write.
So we have the in-kind sponsor Manning Publications. So we are giving away a free book of Deep Learning with Python by
Awesome.
Francis Collett.
That's a great book, actually. Excellent. Okay, so second question based on what he told me. So CNNs have some limitations. Can anyone tell them and any advancements which have been done recently to combat that?
Okay. Yeah.
Paper. Hello. Yeah, there was a paper by Geoffrey Hinton that calls up as a capsule network. So there is a major limitation of a CNN where it doesn't recognize the spatial features very well. So capsule network does that in a very really good fashion.
Cool. Yeah.
Excellent.
You don't want the goodie? So we have another in-kind sponsor, JetBrains. So he's getting 1 year free subscription. So congrats.
Great chapter. Last question?
Yeah. Last question.
Okay, last question around natural language processing. Considering again aspects of transfer learning, do you guys think there is any model which can really do transfer learning like you do in the image space, or what is the best we can do right now?
Hi. There's this new model called Universal Language Modeling by Sebastian Ruder, which does transfer learning, wherein it understands the English language and tries to predict whatever we want to do on that.
Universal language modeling, definitely it has come out recently and worth
Yeah.
checking out. Yep.
Yeah.
Okay. So one more by Manning Publications on Hello Python book. Congrats.
Guys, there are 2 open spaces happening in the second floor. One is upcoming trends in cybersecurity and front-end analysis, second floor, and then we have women in tech.
Thank you so much. Hey.